All right, so yesterday I did an intro to log functions and their graphs. Today I'm going to do some more dealing with logs. We're going to look at common logs, natural logs, and also how you can use these to solve like an equation. So I want to give you some facts first. Common log. A common log has a base of 10. So a log with a base of 10 is what we call the common log. So the way we write a common log is without the 10 showing, all right? So that's understood to be a 10. If you don't see a 10 here, if you don't see any number here, it's understood to be a common log, all right? So that's the main thing. A common log has a base of 10. This is how we write a common log, just log. A natural log has a base e. So a log with a base e is written ln. So when you see ln, this is what it actually means, log with a base e. And I can get into what e is. That's a whole nother few minutes of explanation. But just know e is a number just like pi is a number. So here's my first example. This one wants us to evaluate the log base 2 of 32. Log base 2 of 32. So this is how we're going to start this off. We're doing the log base 2 of 32 is equal to a question mark. All right, so this is what we're trying to figure out. We're trying to figure out what the answer is. So up here, you notice they didn't put a question mark there, but technically that's what's happening. We're trying to figure out what this is actually equal to. All right, so here we go. That means we're going to take the 2, raise it to this question mark, and set it equal to 32. So we're going to raise 2 to a question mark, and that's equal to 32. And that's what we need to write in exponent form. 2 to the blank is equal to 32. So remember how I said if you have to know your powers. If you don't know your powers, you should just list them out, starting with the 0 power. So 2 to the 0 power is equal to 1. First power, that's your 2. 2 to the second is 4, 8, 16, 32, 64, 128, so on and so forth. So you just create a list of powers, and you create the list of powers based on this number, that number. See what I'm saying? So since 2 is my base, then I make sure all my list of powers have a base of 2 because I know it's going to have to come off of this list if I need to move forward over here. And if you look at what I'm equal to, which is a 32, here's my 32. So that means my question mark needs to be a 5. So 2 to the 5th power is 32, which makes the solution here a 5. And a little bit off topic when we talk about powers of 2s. I noticed this not too long ago. I'm not sure if any of you all have ever noticed this. Okay, so I'm an iPhone user. I remember when iPhones first came out, they were 4 gigabytes and 8 gigabytes. Then after that, it went from 8 gigabytes to 16 gigabytes to 32 gigabytes, 64, 128, 256, 512. Guess what? For some reason, the hard drive sizes correspond to powers of 2. I have no idea why. I just wanted to kind of throw that out there. So rational exponents basically is code for talking about exponents that can be written in ratio form, also known as fraction form. A square root is a 1/2 power. Cube root is a 1/3 power. A fourth root is a 1/4 power. And an nth root is a 1/nth power. So whatever this number is, right, that's going to be the denominator. If you don't see a number there, that's understood to be a 2. That's the square root. Square root has a power of 2, so we're talking about a 1/2 now. It's a reciprocal relationship, all right? So my whole reason for letting you know that before I got started with this example is because we're going to have to use that knowledge to figure this problem out. Now, if we can kind of backtrack a few minutes ago, if you don't see a number here, that's understood to be a 10. When you're starting out, go ahead and fill in those 10s when you're starting out until you get used to it. And notice nothing's changed. When we're converting from a log form to exponent form, it's going to happen in this circular motion. So I'm going to raise 10 to the x power, 10 to the x power, and it's going to be equal to the cube root of 10. So that's where it's going to start there. Once we kind of set that up, now we can move forward into figuring out the solution. So there's a process of what we call rewriting, and rewriting is based on facts. So remember what we said about this number, right? This is a cube root. This is equivalent to a 1/3 power. The reason why it's important to be able to go from this format to that format is because you want to be able to see the exponents. Because remember, we're dealing with logarithms. Logarithms establish a relationship between a base and its exponent. So when we're solving for these variables, they have everything to do with exponents and less to do with the bases. Like they're needed, but what we're trying to get solutions for are located in this area. That's why it's important that we see this area at all times. So basically, this is kind of simple. We know what the answer is. X has to be a 1/3 for these two to be equal to each other. So the answer is 1/3. So there's my solution right there, 1/3. And it all happens because my bases are matching up. Now I got my exponents showing. Then it's easier to solve it. All right, so I'm gonna probably do one more example dealing with the logarithms. Tomorrow I'll start looking at natural logarithms. So right now we're just looking at common logarithms and other logarithms, but not the natural logarithm. So here's one problem. We have log base 6 of 1 over the 5th root of 36. So we're going to have to figure out what is this equal to. And remember, all this can be done without a calculator. So I'm going to go into like my thought process, and I'm going to show you how you can actually work through this one. This is actually not a hard problem. So I'm going to do mine live on the board right here. So like I see this has a base of 6, right? And over here I see a 36. The first thing I got to think about or take into consideration is it must have something to do with a base of 6. So instead of 36, you really want to think about this as 6 to the 2nd power. See, that's the first thing you want to do. Now I have a base of 6. I have a base of 6 because all of this is about to come in extremely handy. All right, the next thing we want to think about is, remember what this 5th root means. The 5th root, this is letting you know what your denominator is. And it's going to be the denominator of your exponent. So when you see a 5th root, what you're really thinking about is this being over a 5. See that? And let me rewrite that because that doesn't look good. So now we're looking at a 6 raised to the 2/5 power. And all of this is just me rewriting it. All right, we got one more thing. Now remember, these are based on exponent rules. When I have a power in the denominator, I can take this whole power and move it to the numerator if and only if I change the sign of my exponent. So I'm not going to erase this one. I'm just going to rewrite it right below it. So we have a log base 6, and what I'm looking at is a 6 to the negative 2/5 power. And we're trying to evaluate this, which means that's going to be equal to x now. So I start circular motion. 6 to the x is equal to that. See that? So 6 to the x power is equal to 6 to the negative 2/5 power. My bases match, and there's my exponent. So x is equal to negative 2/5. That's the answer. X is equal to negative 2/5. Solution. Well, I didn't do any verification with the other examples. I knew they were correct, but I just want you to kind of see at least this one. So there's my log base 6, 1 over the 5th root of 36, just like the one on the board. I hit enter, and it gave me this. And remember, if I change that to a fraction, same thing. That's why we were able to get a negative 2/5, is because we were evaluating these expressions using their exponents. Because that's what the log is going to do with the base and exponent so that you can get to the exponent.